Welcome back. In the previous video, I introduced you all to the idea of free radicals, right? So we learned how when you have a molecule of chlorine and then you shine light on it, then you generate two free radicals of chlorine, right? Now you can extend the same idea to a bromine molecule. Will generate 2Br dot, and then a molecule of iodine would also generate two free radicals of iodine. Okay, and then the same idea could also be extended to fluorine as well. Any halogens pretty much would have the same foundational logic. But what we haven't learned in depth is we only looked at methane, right? And what are the products that we generated? I'm just going to recapture all the products. So we generated a CH3Cl. We also generated a CH2Cl2. Okay. We generated a CHCl3, and then finally we generated CCl4. What do you notice in this is, now before this was formed, okay, I'm going to backtrack it. If you remember, we had this, and that's what combined with the remainder of the Cl to make this. The reason I did the methane was for a purpose, again, that was specifically meant to explain that concept in this video. Okay, so before we made this, this is what we had. That Cl was already attached, and then we had the free radical on the carbon. Okay, and again, in the same case, before we made this, we had CHCl2 and dot, right? And then in this case, again, we had this before the chlorine combined to generate it, right? Now, what I'm going to do is underline a few things, okay? This is called, anytime a carbon with 3 hydrogen, we know that it's methyl from, remember, that hasn't changed. Just because it has a radical doesn't mean it's methyl. So this is a methyl radical, okay? Okay, this is we don't want to, ethylene is what I don't think there is a name for it. So I'm just going to call it secondary radical. Anytime you have a carbon, okay, I'm sorry, it should be called a primary radical. Okay, anytime you have a carbon with 2 hydrogens, it's called a primary radical. A carbon with only 1 hydrogen, okay, is a secondary radical. Okay, and a carbon with no hydrogen and a free odd electron is a tertiary radical. I'm just going to write what the 1 degree means. 1 degree means primary, and 2 degree means secondary, and 3 degree means tertiary. Okay, do not confuse 3 for 4. Okay, there's 4 bonds, that's why it's tertiary. It's not because it's 3, it should have been trinary or something. No, I don't think chemistry works that way. So it's important you remember this. Now we will talk about the stability. Okay, whenever, say, a Cl dot, okay, encounters these 4 scenarios, okay, let's say this is like, the Cl dot is right in the middle and it has 4 options that you can go to. Guess what? The first option it'll pick would be the tertiary, because the tertiary radical is the most stable. What that means is when the Cl dot, if it combines with this, would also generate in a more stable product. Okay, radicals are never stable. But what we mean by relative stability is that this would lead to the most stable product. So the Cl dot would prefer to go to this particular molecule right here. Okay, now let's write down the stability of these. So the tertiary radical is the most stable. followed by the secondary radical, followed by the primary radical. Something we have not learned yet, so I'm going to reserve. There's two more that will go on to the left of the tertiary radical, but we have not quite got to that. So let's work with these concepts for now, and then you've got the methyl radical. This is the order of stability. What that means is this is the most stable, and this is the least stable. Okay. All right. So in the next video, so this is what I really want to get across in this particular video is you need to know the stability of radicals before we can learn the next concept. So in the second video, in the third video, when I come back, I'm going to talk to you how does this concept of radical stability and the free radical mechanism that we learned earlier works for compounds other than just methane. Okay, we're going to look at maybe a compound or two and look at the various mechanisms that goes on and the various products that are generated in the process, and then that's where we conclude this part of the free radical reactions. And then, like I said, we have two more. One is benzylic and one is allylic. Okay, and I don't think we've got to them yet. So let's focus on these four first, because you are familiar with, you know, this right now. So I'm going to focus on this, and then in the next video I will walk you through a couple of mechanisms involving this stability part of it. All right, so stay tuned.